Hello, beautiful souls, and welcome to my channel. Thank you for joining us on this exploration of 125 smoothbore ammunition. We hope you find it enlightening. The following is a list of ammunition fired by the 125 smoothbore gun series used in the T-64, T-72, T-80, M84, T-90, PT-91, T-14 Armata, and other tanks derived from those designs, as well as the Sprut anti-tank gun. With our foundation established, it's time to explore APF-SDST and its relevance to our overarching theme. Armor-piercing fin-stabilized discarding Sprut APF-SDS using a Sprut and tracer APF-SDST, typically used against other modern tanks. There are different ways to measure penetration value. NATO uses the 50% criteria against urban steel, while the Soviet Russia standard is higher 80% had to go through. Get ready for a captivating exploration as we unravel the layers of UBM and their profound significance. Entered service in 1962. The projectile is margin steel, country of origin, Soviet Union, projectile dimension 410-10. 1 projectile weight including Sprut 5.67, projectile weight 3.6, muzzle velocity 1800 ms, muzzle energy 5.8 mj, penetration 245 m at 2000 m, 140 m at 2000 m, energy at 2000 meters is 4.2 mj. Now let's shift our attention to UBM. Entered service estimated in 1968. Essentially the same as the UBM projectile with a tungsten carbide, country of origin, Soviet Union, projectile dimension 410-10. 1 projectile weight including Sprut 5.67, projectile weight 3.6, muzzle velocity 1800 ms, muzzle energy 5.8 mj, penetration. As we enter this new phase, let's uncover the impact of UBM on our broader topic. Entered service estimated 1972. A slightly longer UBM projectile, country of origin, Soviet Union, projectile dimension 435-12. 1 projectile weight including Sprut 5.9, projectile weight 3.9 including 2.9 and 0.27, tungsten carbide plug, muzzle velocity 1785 ms, muzzle energy 6.2 mj, penetration 400 m at 2000 m, 150 m at 2000 meters. Let's now shift gears and explore UBM through a critical lens, uncovering its strengths and weaknesses. Entered service estimated 1972. An export version of the UBM-15 without the tungsten carbide plug. Hence, it is an all-steel penetrator with inferior performance. Country of origin, Soviet Union, projectile dimension 415-12. 1 projectile weight including Sprut 5.9, projectile weight 3.9, muzzle velocity 1780 ms, muzzle energy 6.2 mj, penetration 150 m at 2000 meters. Now, let's shift our attention to UBM Zokolka. UBM Zokolka. Entered service 1976. Tungsten carbide penetrator core sheathed in steel. Enlarged cap helped to increase positive normalization and hold a much larger penetrator. Country of origin, Soviet Union, projectile dimension 411. 1 projectile weight including Sprut 6.55, projectile weight 4.485, muzzle velocity 1785 ms, muzzle energy 7 mj, penetration 420 m at 2000 m, 170 m at 2000 meters. Prepare yourself for an eye-opening discussion on UBM Nadfil 2 in the upcoming portion of this video. UBM Nadfil 2. Entered service 1982. depleted uranium nickel iron alloy sheathed in steel, country of origin Soviet Union, projectile dimension 415-12, 1 including 215 core, projectile weight including subit 6.55, projectile weight 4.85, muzzle velocity 1700 ms, muzzle energy 7 mj, penetration 360 at 2000 m, 210 at 2000 meters. Let's now turn our attention to Armata and uncover the fascinating insights it brings to the table. Armata entered service 1983. Tungsten nickel iron alloy penetrator core sheathed in steel. Utilized new high-energy propelling charge. Penetrator is base installed to prevent deflection during penetration against multi-layered composite armor. Improved penetrator cap made of aluminium alloy, country of origin Soviet Union, projectile dimension 395 mm, 1 projectile weight including subit 7.05, projectile weight 4.8, muzzle velocity 1720 ms, muzzle energy 7.5 mj, penetration 410 at 2000 m, 200 at 2000 meters. As we venture forward, let's examine Armata in detail and gain a deeper appreciation for its significance. Armata entered service in 1985. The projectile is an integrated depleted uranium nickel zinc alloy penetrator, country of origin Soviet Union, projectile dimension 318-13, 1 projectile weight including subit 7.05, projectile weight 4.85, muzzle velocity 1700 ms, muzzle energy 7 mj, penetration 395 at 2000 m, 230 at 2000 meters. Get ready to immerse yourself in the world of Armata as we examine its impact and relevance. Armata entered service in 1986. The projectile is double tungsten alloy rod sheathed in low melting point alloy covered with steel, intended to increase penetration against non-explosive reactive armor (NEI) such as Chobham armor. Is slowly being replaced by newer models such as Armata, country of origin Soviet Union, penetrator dimension 532-17, 1 round weight 20.4, projectile weight 4.85, projectile weight including subit 7.05, muzzle velocity 1700 ms, muzzle energy 7.1 mj, penetration at against standard steel target. Let's now turn our gaze towards Armata and explore the fascinating connections it has to offer. Armata, from 1994, remained experimental and eventually evolved into the meaning the outside design remained the same. The length of cartridge remained pretty much unchanged, but the penetrator was further improved from the initial jacketed design, which was improvement over the standard country of origin Russia, penetrator dimension 517-25, 1 round weight. Kilograms, projectile weight including subit 6.95, projectile weight 4.6, muzzle velocity 1750 ms. Muzzle energy 7.04 mj, penetration at against standard steel target. With the groundwork laid, let's now examine Armata and its connections to our previous discussions. Armata, currently in experimental phase, most famously seen at the Expo 2019 alongside 42 and 60. Uses the initial jacketed penetrator, but the cartridge is shorter over the lecolo, designed to fit in the standard autoloader, and is most likely to replace the standard 42 as main service round country of origin Russia, cartridge dimension penetrator dimension 517-26, 1 round weight. Kilograms, projectile weight including subit. Penetrator weight. Muzzle velocity 1700 ms, muzzle energy. Penetration 218 at against standard steel target. As we progress, let's zoom in on Spinets and examine its role in shaping our overall narrative. Spinets entered service in 1991. Uses a new advanced high-elongation uranium monoblock penetrator country of origin, Soviet Union penetrator dimension, 546 21.84, 1 round weight. Kilograms projectile weight including subit. Projectile weight 4.85 muzzle velocity, 1700 ms muzzle energy, 7.4 mj penetration, Now, let's redirect our focus towards Spinets 2 and discover its significance in our narrative. Spinets 2 entered service 2016. The new round uses a new subit design and a tungsten alloy penetrator of increased length compared to prior generation Russian APF SDS ammunition. Used on them with new autoloader cartridge dimension, 735 penetrator dimension, 614.2829, 1 round weight. Kilograms projectile weight including subit, 8.4 penetrator weight, muzzle velocity, 1660 ms muzzle energy, 12.1 mj. Penetration, at against standard steel target. As we transition, let's shed light on Spinets 1 and its relevance to our ongoing exploration. Spinets 1 entered service 2016. Uses a new subit design and a new depleted uranium penetrator. Used on M5 with new autoloader country of origin, Russia cartridge dimension, penetrator dimension, 614.2829, 1 round weight, 22 projectile weight including subit, 8.5 penetrator weight, muzzle velocity, 1650 ms muzzle energy, 12.1 mj penetration, Moving forward, we'll be taking a closer look at Vacuum 1. Vacuum 1 uses a new subit, reported to be uranium alloy, for use on cannon on T-14 Armata country of origin, Russia projectile dimension. Round weight. Projectile weight including subit. Projectile weight, estimated 11 muzzle velocity, 2050 ms muzzle energy, MJ described and probably refer to high explosive shell penetration, estimated 850 to 1000 at. Get ready for an exciting part as we dive into Vacuum 2. Vacuum 2 uses a new subit, identical to in dimensions, the difference being that the projectile is made out of tungsten country of origin, Russia projectile dimension. Round weight. Projectile weight including subit. Muzzle velocity. Muzzle energy. Penetration, steel target. Without wasting any more time, let's jump into the fascinating world of 125I. First generation Chinese subit round in service since 1993, also license produced by Pakistan country of origin. China projectile dimension, 554 round weight, 21.3 projectile weight including subit, 7.37 muzzle velocity, 1730 ms muzzle energy. Penetration, at against 4,340 steel. Get ready for an exciting part as we dive into DTW 125. Second generation Chinese subit round introduced in 1999. Initially 125IM acted as the export version with reduced velocity, but with the introduction of 125, the DTW 125 itself became exported under the name country of origin, China projectile dimension, 642 round weight, 21.36 projectile weight without subit, 4.1 muzzle velocity, 1740 ms muzzle energy. Penetration, at 200 at against 4,340 steel. Now, let's redirect our focus towards 125 and discover its significance in our narrative. third generation Chinese subit round, which was introduced in 2010 and the subject of a data leak on the War Thunder forum in June 2022. Leaked data is used here. This performance value is identical to value shown on Chinese state media. Country of origin, China. Projectile dimension, 665 round weight. Projectile weight including subit. Muzzle velocity, 1760 ms. Muzzle energy. Penetration, at against 4,340 steel. With the groundwork laid, let's now examine TAPNA and its connections to our previous discussions. Produced by MSM Group in Slovakia. The penetrator is made from tungsten, country of origin, Slovakia. Projectile dimension, round weight, 20 projectile weight including subit, 7.15 muzzle velocity, 1690 ms. Muzzle energy. Penetration, 270 at 2000 meters at against standard urban steel target. As we enter this new phase, let's navigate the complexities of HEATFS and discover its practical applications. High explosive anti-tank HEAT fin stabilized HEATFS rounds, typically used against lighter or older tanks and armored personnel carriers. In this part of the video, we'll be diving deep into OPC and unraveling its profound impact. Entered service, a country of origin, Soviet Union. Projectile dimension, 618 projectile weight, 19 max dispersion, 0.21 mil. 0.21 rad. Muzzle velocity, 905 ms. Charge, shaped charge, steel liner, IX1 IDX phlegmatized with 5% wax, I-238 detonator. Penetration, 420 RHA at 0 degrees. In the next segment, we'll be exploring OPC and its implications for our subject matter. Entered service 1968, replacing steel liner with a copper liner. M means copper in Russian, uses IV-15 detonator. Due to Soviet Union's copper economize policy, production of the model is limited. Penetration performance claimed to be 10% higher than steel liner version. Country of origin, Soviet Union. Brace yourselves for the next chapter, where we'll be dissecting OPC. Entered service, a country of origin, Soviet Union. Projectile dimension, 618 projectile weight, 19 max dispersion, 0.21 mil. 0.21 rad. Muzzle velocity, 905 ms. Charge, shaped charge, steel liner, oakfall phlegmatized HMX with 5% plasticizer, IV-15 detonator. Charge weight, 1.62 penetration, 415 RHA at 0 degrees. Now, let's shift our attention to OPC. Improved version, replacing steel liner with a copper liner. As we enter this new phase, let's analyze OPC from different angles and evaluate its significance. Entered service, estimated 1975. Introduced wave shaping booster. Country of origin, Soviet Union. Round weight, 29 projectile dimension, 618 projectile weight, 19 max dispersion, 0.21 mil. 0.21 rad. Muzzle velocity, 905 ms. Charge, shaped charge, steel liner, oakfall phlegmatized HMX with 5% plasticizer, IV-15 detonator. Penetration, 500 RHA at 0 degrees. In this section, we'll be deep diving into OPC, unraveling its complexities and uncovering valuable insights. Improved warhead. Entered service, estimated 1978, replacing steel liner with a copper liner. Improved wave shaping booster. Country of origin, Soviet Union. Projectile weight, 19.02 muzzle velocity, 905 ms. Penetration, 515 RHA at 0 degrees. Let's now shift gears and explore OPC through a critical lens, uncovering its strengths and weaknesses. Entered service, estimated 1980. Enhancements to improve reliability of the copper jet formation. Country of origin, Soviet Union. Projectile dimension, 618 projectile weight, 19 max dispersion, 0.21 mil, 0.21 rad muzzle velocity, 905 mischarge, shaped charge, copper liner, oakfall phlegmatized HMX with 5% plasticizer, IV-15 detonator penetration, 515 RHA at 0 degrees. Let's transition to and uncover its significance. Entered service estimated 1982. Material be depleted uranium alloy liner to enhance penetration of advanced composite armors like Chopin. Country of origin, Soviet Union. Projectile dimension, 618 projectile weight, 19 muzzle velocity, 905 mis penetration, 715 RHA at 0 degrees. In this section, we'll be exploring Kirk. Entered service estimated country of origin, Soviet Union. Muzzle velocity, 905 ms. Without further ado, let's move on to the topic of Kirk break. Entered service estimated 1988. A new type of explosive filling was applied, which improved focusing of the jet stream. Country of origin, Soviet Union. Round weight, 28.4 projectile dimension, 618 projectile weight, 18.4 muzzle velocity, 915 mis penetration, to RHA at 60 degree tenon charge. As we progress, let's zoom in on Kirk and examine its role in shaping our overall narrative. Country of origin, Soviet Union. Projectile weight, 18.4 charge weight, 1.62 muzzle velocity, 915 mis penetration, estimated at 810 charge HEAT. Let's now turn our gaze towards Kirk's start and explore the fascinating connections it has to offer. First seen publicly in 1998. Reportedly a triple-charge warhead intended to reduce efficiency of NERA elements. A country of origin, Russia. Projectile weight, 18.4 charge weight, 1.62 muzzle velocity, 915 mis penetration, estimated at 800 triple charge HEAT. As we progress, let's zoom in on HE-Frag-FS and examine its role in shaping our overall narrative. High explosive fragmentation fin stabilist. General purpose rounds for use against infantry, bunkers and light vehicles and other soft targets. In the next segment, we'll be exploring the FF and its implications for our subject matter. Entered service in 1962. Uses the IV-21 detonator, mass equals 0.431, reliability equals 0.98. The 90% lethal zone for infantry is reported to be 40 meters wide and 20 meters deep. Country of origin, Soviet Union. Round weight, 33 projectile weight, 23 muzzle velocity, 850 ms. Max dispersion, 0.23 mil, 0.23 rad. Charge weight, 3.148 charge, TNT. Moving forward, we'll be taking a closer look at FF. Entered service in 1970. Uses the IV-21 detonator, mass equals 0.431, reliability equals 0.98. The projectile creates between 600 and 2000 fragments. The body is made up of ERK steel or high fragmentation steel for modern projectiles. Modern projectiles creates up to 2,500 effective fragments. A country of origin, Soviet Union. Round weight, 33 projectile weight, 23 muzzle velocity, 850 ms. Max dispersion, 0.23 mil, 0.23 rad. Charge weight, 3.4 charge, IX 273% RDX, 23% aluminium power, phlegmatized with 4% wax. 3.4. Let's now zoom in on the FIF and uncover the hidden gems that lie within. Entered service in 2014. Uses the OVM-18 programmable detonator. The projectile contains 450 tungsten rods, each weighing 3 grams, and creates 2,500 fragments in a cone formation ahead of the projectile when a burst mode is set. A burst mode for use against infantry, light vehicles and helicopters, delayed mode use against bunkers and other constructions. Is currently used on the M5 gun, mounted on the team country of origin, Russia. Round weight 33 projectile weight 23 muzzle velocity 850 ms. Max dispersion 0.23 mil. 0.23 rad. Charge weight 3 charge IX to 73% RDX 23% aluminium power, phlegmatized with 4% wax 3. Our focus now turns to offshore and an important aspect of our discussion. Entered service in 1975. Uses the OV-17 detonator. Free use against wide area infantry and light vehicles. Time of detonation setting is mechanical. For modernization, the shell fuse could be set automatically by improved ANIT systems or Kalinus systems, which are available on the T-Chick Commander tank or the regular main battle tanks such as the T-EA Team TU and the T-14 Armata main battle tank country of origin, Soviet Union. Round weight 31.3 projectile weight 21.3 muzzle velocity 900 ms. Projectiles contain 4,700 flecket weighing 1.26 g each. Charge weight 0.08 to IX1. Get ready for an exciting part as we dive into ANIT. Entered service in 1988. Uses the OV-12 programmable detonator. A part of remote detonation system ANIT on T-UK Commander tank country of origin, Soviet Union. Round weight 31.3 projectile weight 21.3 muzzle velocity 900 ms. Projectiles contain 4,700 flechetis weighing 1.26 g each. Charge weight 0.08 to IX1. As we progress, let's zoom in on Cobra and examine its role in shaping our overall narrative. The Cobra N8TO reporting name is AT8. Songster is also fired from the 125 main guns of the T-64 and T-80 series of tanks country of origin, Soviet Union. Projectile weight 23.2 warhead weight 4.5 guidance system, radio command guided range 104,000 meters. Penetration estimated at 700 mm after ER8 tandem charge HEAT. As we progress through this video, let's now turn our gaze towards Reflex. Spare and Reflex N8TO reporting name. A T-11 sniper anti-tank guided missile has semi-automatic command to line of sight SACLOS laser beam riding guidance and a tandem-shaped charge HEAT warhead. It has an effective range of 75 m to 5,000 m and takes 17.6 seconds to reach maximum range. Reflex can penetrate about 900 mVh after ERA tandem charge HEAT. Brace yourself for an in-depth analysis as we navigate through UG Sprinter and its far-reaching implications. Designed for the AM gun on T-14 Armata tanks, the UG Sprinter has millimeter-wave semi-automatic command to line of sight SACLOS guidance and a tandem-shaped charge HEAT warhead. It has an effective range of 50 m to 12,000 m and can penetrate 950 m of steel rolled homogeneous armor after explosive reactive armor ERA. It can also engage low-flying air targets such as helicopters. Country of origin, Russia. Projectile weight. Warhead weight. Guidance system, millimeter wave range, 12,000 meters. Penetration, estimated at 950 millimeters after ERA tandem charge HEAT. Now let's delve into the intricacies of Sokol-1 and explore its various aspects. The Sokol-1 guided shell is fired from the 125 main gun. It borrowed design from the artillery shell of Santomitra M and both have very similar appearance, but with an added shaped charge cap into its design similar to the Copperhead, intended to defeat heavily armored targets. It uses the technique that is referred to as the Russian concept of impulse corrections RCIC, an impulse steering flight control system to correct the projectile's trajectory. Country of origin, Russia. Projectile weight 23 muzzle velocity 850 ms. Guidance system, semi-active laser passive target contour based range 0.15 direct fire 12 indirect fire warhead, high explosive millimeters penetration shaped charge. Now, let's shift our perspective and explore UGF through a fresh lens, unlocking new perspectives. The UGF guided shell is fired from the 125 main gun. Its design was modified from a missile, removing the rocket motor and replacing it with an extra thermobaric warhead, turning it into a guided shell. Its range was decreased to 3.5 km, and it is claimed to have 3 times the explosive power of regular thermobaric variant 125 guided missiles. Country of origin: Russia. Projectile weight 16.5 km, muzzle velocity 284 ms. Guidance system: laser beam. Riding range 0.13.5 km. Warhead: thermobaric, estimated 15 TNT equivalent. Remember, knowledge is power. Keep learning, growing, and exploring.